Okay, so in my last video I discussed about how I did the bisection method program. Now in this I will discuss how I did the regular-Falsi or the false position method program. So these are the header files, this is the function, uh, and I have to find within a range where the root lies for this x cube minus 2x minus 5. So a and b, similar to the bisection method, a is the starting and b is the ending root, and we will see all this next. Now in this, actually in bisection method what we did was there was a and b, and in the difference is that here a and b is the points are there and you have to approximate a line that's passing through these points, this and this, and the approximate root is lies here, and the formula for the approximate root is this, where xu is the upper limit. It means the functional value of the upper limit, which is this one. xl is the lower limit, which is this one. Again xl is the functional value of the lower limit, this one, and this is the upper limit, that is this point, and these are the functional values, which is equal to xr. This is the approximate root. So we first take the value of the starting and the ending point. We find c and v similar to the bisection method and check that if c and v is greater than 0, then no root exists. That condition I have described already. That is, if the b point lies here or the a point lies here, then the functional value, if we multiply the functional value, it will be a positive. So there is no chance of a root lying in that range. Now if either of them is 0, if c is 0, then a is the root. If v is 0, then b is the root. Now the condition comes when c into v is less than 0. So we first find this value. Now this is the approximate root, the same formula that is used. See that the functional value here, just see, functional value into lower limit. So as you can see, this is the functional value of the upper limit into the lower limit minus functional value of the lower limit into upper limit minus the difference in the functional value. So this is the approximate root. Now first we check that if this root is equal to 0, it means that, as we know, that root is also known as zeros of the equation. So if we put that value, so as I was saying, that the root is also known as the zeros of the equation. So if we put this value, then if we get a 0, then it's definitely a root. Then it will break out from this while loop and it will print the root. Else, again, that condition is checked, that if the approximate root lies here, then we check the functional value here and functional value here. We multiply them and check whether it is negative or not. Similarly, if the approximate root lies here, we check the functional value here and the functional value here. We multiply them and check if it is negative or not. If it is negative, then there is a possibility that the root will lie in that range. So these are the conditions, and we finally modify the range and come out of this loop. Now this one, if you solve any theoretical problem, you will understand that the root either tends towards a or towards b. So if the difference is less than this value, then it will break out from this loop. So that is it.